Okay, so if you're working in media or maybe building in tech, or honestly, even if you've just talked to a customer service bot recently, you've definitely heard the term NLP, natural language processing. It's kind of everywhere, right? Behind almost every digital interaction we have, translating emails, search results, you name it. But have you ever really stopped to think about, how deep it goes? How we got from really simple rules to AI that can write, well, almost anything.
Yeah, that's the thing. NLP is so foundational to AI, but its history, the sort of philosophical journey it took and the big tech breakthroughs, they often get glossed over. So our mission here in this deep dive is to give you that shortcut, a solid understanding of the whole NLP story, pulling out the really key stuff from the sources.
Okay, let's unpack this. We're framing this as a kind of NLP odyssey. We'll trace it right back to the roots, look at those early, sometimes kind of clunky attempts to get machines to handle language, all the way up to the big shifts, the architectural revolutions that brought us to, well, today's generative AI. It's really a story about this long, often tough quest to teach machines to genuinely understand us.
Yeah, that story really starts with history and, interestingly, philosophy.
Right. Because for those of us using these tools every day, understanding the origins is important. If you train history, you see NLP wasn't just some side project in AI. It was absolutely core. I mean, if the big goal was thinking machines, then those machines had to grapple with human language, didn't they?
Exactly. And what's really fascinating, looking at the sources, is that building NLP wasn't just an engineering puzzle. It was deeply tangled up with philosophical questions from the start. That second area the material points to, the philosophical roots, shows this ongoing debate about what understanding even means for a machine.
What kind of debates are we talking about?
Well, the really fundamental stuff driving the field goes back to thought experiments, questioning intelligence itself. Think about early pioneers wrestling with this. Is a machine just shuffling symbols around, following rules, or can it actually grasp the meaning behind them? This comes from things like the Turing test, or arguments like Searle's Chinese room experiment, which really pushed on whether manipulating syntax is the same as understanding semantics. So the field kind of emerged because people had to figure out, how do we even begin to program things like grammar, meaning, context, even intent into a machine?
Ah, okay. So when, say, a media company uses NLP to gauge sentiment on social media, or a tech team builds a translation app, they're actually still dealing with that old philosophical problem. Can the machine really understand the text it's processing? That context helps explain why the first tries were so hard, right?
Absolutely. That philosophy directly shapes the practical tools you use. Like you said, those early systems, they had to rely on these incredibly rigid handwritten rules, very brittle. They only worked if your sentence perfectly matched the grammar and words they already knew. It was like trying to solve the philosophical problem by just writing down all the rules of language.
Wow. Yeah, that sounds incredibly limiting.
It really was.
Yeah.
And that leads us nicely from the why the philosophy to the what happened, the actual impact and evolution. So how important has NRP been in shaping, the digital world we live in now? I mean, seriously, think about it. Without systems that could process and sort through mountains of text effectively, things like the internet, modern search engines, they just wouldn't exist as we know them. It's completely foundational. And to really grasp that importance, we need to look at those landmark moments, the key events highlighted in the sources that really shifted the field. These weren't just about faster computers. They were fundamental changes in how we even approached the problem of language.
Okay, let's get specific. What were those big shifts?
Well, the first era, as we kind of touched on it, was the rules-based era. Think systems like ELIZA back in the 60s. Fascinating stuff, psychologically, but totally reliant on programmed grammar and pattern matching. They couldn't handle the ambiguity, the sheer messiness of how people actually talk or write. They were essentially clever scripts. And the field sort of hit a wall there because human language is just too varied, too unpredictable for rigid rules alone. That frustration led to the second major shift, starting around the 80s and really taking off in the 90s, the statistical era. This was a huge insight. Maybe probability works better than perfect grammar? Systems started to move away from trying to understand meaning directly and instead began calculating the likelihood of words appearing together.
Okay, here's where it gets really interesting. Because that statistical approach, that's basically what built the modern web, isn't it?
Precisely. That shift, you see it with things like IBM's early work on hidden Markov models, statistical machine translation. It was revolutionary. Instead of linguists spending ages writing thousands of grammar rules, you could feed the system huge amounts of text, like massive text corpora, and it would learn the probabilities itself. That's scalability. That's what let companies build effective search engines, spam filters, process billions of web pages.
But wait, that move going from trying for real understanding to just optimizing probability, didn't that kind of sidestep the original philosophical goal?
That's a really sharp point.
Yeah.
And yet, many people argued exactly that. They said we were just building very sophisticated pattern matchers, parrots essentially, not truly intelligent systems. But that statistical approach, even if philosophically debatable, critically paved the way for the third and current paradigm, deep learning. This really kicked off around 2010 and then went into overdrive with the introduction of the transformer architecture in 2017.
Right. Now we're into the current AI boom. For our audience in media and tech focused on scale and capability, what made the transformer such a game changer?
Okay, so the transformer basically cracked two major problems: handling long-range context and language and doing it fast. Older deep learning models, like RNNs, had to process words one by one sequentially, which gets really slow and makes it hard to connect words far apart in a sentence. The transformer, using this clever idea called the attention mechanism, lets the model weigh the importance of all words in the input simultaneously. It can see the whole sentence or paragraph at once. This lets it grasp long-distance relationships between words much better, and crucially, it allows for massive parallel processing during training and inference. That parallelization is what enabled the sheer scale of the large language models that you see in things like GPT today.
Got it. So we went from hand-coded rules to statistical chances and now to this massive parallel context-aware processing. That really explains the power and speed of the tools we're seeing everywhere now.
Exactly. Which brings us neatly to today. So who's using NLP now? Well, the short answer is pretty much any organization dealing with large amounts of text data, which in media and tech is basically everyone, right? NLP is like the hidden plumbing powering content curation, personalization engines, customer service bots, market analysis. Yeah, the source material really emphasizes its use in things like building those sophisticated recommendation algorithms, the ones deciding what news article or video you see next, and also in large-scale data tools that researchers use to track public opinion or market trends by analyzing vast amounts of text.
And for people working in those fields, its importance really can't be overstated. It's not just about, generating cool text, it's about core utility. When we talk about how critical NLP is, it's recognizing just how deeply embedded it is in everyday tech. It's essential. I mean, without fast, accurate NLP, modern search ranking just fails. Content moderation on social platforms, impossible at scale without it. They'd be unusable.
Absolutely. And think about accessibility, too. Voice assistants like Siri or Alexa, dictation software that's all pure NLP in action. For media companies with global reach, translation and localization tools have gone from clunky statistical methods a decade ago to near real-time utilities, all thanks to these deep learning models. It really is that essential utility layer now.
It truly is the infrastructure. Okay, so that naturally leads us to the final question. Where does NLP go from here? Looking at the future horizons discussed in the material, what are the big potential directions or challenges we should be keeping an eye on?
Well, the clear trajectory seems to be towards more complex, multimodal systems. We're already seeing text generation mixing seamlessly with image and even audio generation. The next big step appears to be creating truly unified model systems that can understand language, interpret a picture, maybe analyze audio, all within the same framework. This could lead to incredibly realistic synthetic media and experiences.
Right, and that generation aspect is huge for media folks. Things like automated script generation, creating complex summaries of events, hyper-localizing content automatically. It's pushing the boundaries of what machines can create, not just analyze.
And if we connect this to the bigger picture, the field seems to be pushing beyond just predicting the next word accurately. It's moving towards deeper contextual understanding, better reasoning, maybe even common sense. The massive challenge, though, technically speaking, is managing the sheer scale. Training these enormous models takes incredible amounts of data and computing power, making them efficient enough to run effectively and affordably in real-world apps. That efficiency, the whole cost versus capability trade-off, that's going to be a major focus for the next few years, I think.
Wow, okay, that really was an odyssey. We went from those early philosophical debates about machine meaning through the big shifts, rules, stats, deep learning, transformers, and landed on just how critical NLP is today, like digital oxygen. So what does this all mean for us, especially in media and tech?
Well, I think it means we've built systems that can automate and scale communication in ways that, honestly, the early AI pioneers could only dream about. We've gone from machines just processing language to machines actively shaping communication itself. So maybe the provocative thought to leave you with is this. As these large language models get better at generating hyperlocalized news, writing summaries, automated content, where does the human editorial judgment fit in? When does an algorithm summarizing a complex issue start to subtly advocate for a certain viewpoint, just by how it selects and phrases things? And what kind of guardrails or oversight do we need to build to make sure the information being generated at this massive scale stays, grounded and reliable? That feels like the next big challenge, not just technically, but ethically for everyone relying on these powerful tools.